Hello there, welcome to the second presentation on Introduction to Determinants of 2 by 2 matrices. This presentation is going to take us to a position where we're ready to deal with determinants of 3 by 3 matrices, including computation of their inverses. Once you've understood the first presentation where we introduced the determinant and briefly the inverse of a 2 by 2 matrix, I think it's important to do the following practices. For example, let's say we're given a matrix like A, which is, let's take the matrix we started with in that system of equation, which was 2, 3, 3, 1. That's the matrix we're given there. Now, if somebody would say now, find the determinant, what did you do? It's just simple. Say A. Please notice that the lines I'm using here are straight lines. These ones are square brackets. Don't confuse them. If you mix them up, wrong notation means wrong mathematics. Yes, there's a difference. There's a difference. Don't make a mistake. Then we come here, you write, so you calculate the determinant. At the end, I want you to tell me whether the matrix is singular or is non-singular. So how did you calculate the determinant? Say the principal diagonal here will give us 2 times 1. And the second diagonal here is going to give us, there's a minus sign there, 3 times 3. We end up here with a 2 minus 9, and we get a minus 7. Singular or non-singular? What are we going to say? Come again? Singular. Non-singular. So therefore, A is non-singular. And then if it's non-singular, therefore A has an inverse. Altogether. Remember, non-singular means the determinant is not equal to 0. Remember, at the inverse, we multiply by 1 over the determinant, but you cannot divide by 0. So that will guarantee whether there's a matrix inverse or there's no inverse altogether. Now, if we remember what we saw before, we were given A, which was A, B, C, D. We came up with what that A inverse was 1 over AD, BC, or in short, 1 over the determinant. Then this was D, A, and then there was minus B there and a minus C there. So now what can we do? We can use this to find the inverse of this matrix. We already got what? The determinant, isn't it? So what do we do? We just say now A equals to 2, 3, 3, 1. The inverse, we need 1 over minus 7. And then what do we do? Check what's happening here. Check what's happening. Practical what's happening here. You interchange A and D. A and D. So we're going to have here 1 and 2. What's the next thing? You change the signs. What do we have there? Minus 3, minus 3. And then somebody wonders, is this really an inverse of that? Let's multiply. Maybe let's do it in this order. It doesn't make any difference. I just want to do this order. Why? Because of this 1 over 7, isn't it? So I'm going to put this 1 over 7 here as minus 1 over 7. And then I'm going to put here as 1 minus 3, 2. Multiply by, we do our multiplication, take this 2, 3, and transpose it there. What are we going to have there? We're going to have 2 times 1 plus minus 3 times what? 3. Did you see that? And then what's the next thing here? We're going to now multiply here minus 2 minus 3 times 2, which is going to be 2 times minus 3. Check how I'm handling my minus signs there. My signs, I'm putting them in brackets, plus 3 times 2. We're multiplying here in this row with this column. And then next, we're now taking this one. It's going to be 3 times 1 plus 1 times minus 3. Then when we come to this row, we've got minus 3 times minus 3 plus 1 times 2. Can still keep our 1 minus 1 over 7 there. Then we simplify here. What do we get here? We get minus 9 plus 2. That's 7. And here what you get? You get a minus 6 and a 6. That's 0. And here what you get here? Get a minus 3 and a 3. Added, that's 0. And here you get a minus 9 plus 2. Added, minus 7. There's something wrong there. Do you see what's something wrong? I didn't put a minus 7 here. You see it when I see it. Huh? So what do you do? we go back to matrix multiplication by a scalar. This is a scalar, it's a number. Coming in, multiply here, we see what's going to happen. We simply get 1, 0, 0, 1. And therefore, effectively, this is an inverse. What I'm going to do now, I'm not going to do any more of this. I've just calculated one determinant. I calculated an inverse. The next thing what to do yourselves, you've got to practice in order to get familiar with this thing. Let's suppose we've got a b here. So then in the case here which we're working here, we'll simply get this thing as what? As 3 times 4 minus 1 times 2. Do you see that? And then what you get here? You get a 12 plus 2, which will give you 14. And the 14 is not equal to 0. Then immediately you can say, therefore, B has an inverse. Then we can go and search for it if we need it. But once we see that it's equal to 0, we stop searching for an inverse because it's not going to exist. Am I making sense? Okay. So you can go and practice and continue that one. All together. Okay. So now what I want to see now, from the first matrix we started with this one, which was 2, 3, 3, 1. And we end up with something like this. A inverse equals to, was it a minus 1 over 7? Minus 1 over 7 multiplied by, that's what we can end up with, isn't it? Yes. There's one thing which we're clear of here. We know about minus 7. We know about minus 7. You can calculate it by 2 times 1 minus 3 times 3. Altogether. But this thing here, this matrix here, this matrix, I'm just going to call it A second here. I'm just going to call it A second. This matrix here, it could be looking like a kind of a mystery. How did you get there? Now what I want to do now, once we make sense of how we got here, we're going to know how to get an inverse of a 3 by 3. Do you hear what I'm saying? Once we make sense how we can get here, we're going to get idea of how to get an inverse of a 3 by 3. And we're also going to get an idea of how to get a determinant of a 3 by 3 without using systems of equations. All together. So I want you now to get a systematic way of getting here without necessarily using a system of equation. What did I say here? I said examples and more. So that is the more. Now observe. I'm just saying open your eyes, look and see something is happening here. If I talk in terms of signs, plus and the minus, just check that if I move from here and go this way, up back here, in terms of sign, it's a plus, minus, plus, minus, plus, minus, plus, minus. It's an oscillation of some sort. On, off, plus, minus, plus, minus. Do you get it? No. If I move from any point, doesn't matter where I move from. If I move from here and go the same way, it will be minus, plus, minus, plus, minus, plus. So wherever I move, there's an oscillation. All together? Okay. Now let's do this. You must give this. Notice that this one is at position 1, 1. What is 1, 1? First row, first column. And notice here, this minus is at position 1, 2. And this one is at position 2, 1. And this one is at position 2, 2. If you look at those positions there, I'll put them like this. If I add these 2, I get a 2. It's an even number. If I add these 2, I get a 3. It's an odd number. If I add these 2, I get a 4. It's an even number. If I add these 2, I get a 3. It's an odd number. That is beautiful. So now, from here now, I know how to get these signs. The signs I'm talking about here changing. I know how to get them. How am I going to get them? I'm going to simply say S for sign, row, column, equals to minus 1 to the power r plus c. Check that. If I'm 1, 1, I'll get minus 1 to the power 2. It's positive. If I'm 1, 2, I'll get minus 1 to the power 3. Negative. If I'm 2, 2, I'll get power 4. Positive. If I'm that, I'll get power that. No. Listen to me. I didn't say you know this thing, but I'm showing you, which means it's something you must learn. If something is surprising you, tell me that this is surprising you. Then I understand why it's surprising you. I'm just showing you. Remember, how did we get these minus signs here? We got them from the big system of equations, isn't it? How many were there? There were 2. Now, if we go to a 3 by 3 matrix, we're going to have 3 systems of equations. So before you make sense of an inverse of a 3 by 3, you will have to go through the 3 systems of equations. I'm running away from that. And in 3 systems of equations, how many unknowns are going to get? 3 each. We're going to get 9. It's going to be a tedious thing. Altogether. So this idea which I'm coming up with here is to cut down those 9, searching for 9 unknowns. Just understand it. If you don't understand something, tell me. What I'm doing is I'm trying to reveal the mystery of those signs. Those signs, they are oscillating, plus, minus, plus, minus. I'm revealing it, and I'm revealing it this way. Let's stop here, and they will tell me where exactly are you getting surprised. I said observe. I said observe the signs in these entries. I can move in any direction. They go plus, minus, plus, minus. Did you see that? So you are fine. All together. And then next thing, observe that these signs are at positions 1, 1, 1, 2, 2, 1, and 2, 2. Did you notice that? Okay. Observe. When I add these numbers, the position numbers here, I get a 2. That's an even number. Did you see that? And I add these 2, I get a 3. That's an odd number. Did you see that? And so on. So I'm saying now, I can actually get now a formula for finding those signs. I can get a formula for finding those. Are we together? Okay. Let's come to the next thing now. Let's wait for this. Let's leave this. Let's leave this for a while, just for a while. But we know it, isn't it? Okay. Let's take A. A is, let's come up with something here. Let's give the notation. I'm going to call this M. No, I don't want this. I'm going to call this A 1, 1. Notice my A is a capital letter. Altogether. It refers to what? To matrix A. Altogether. And then when I say A 1, 1, I simply mean in A, drop row 1 and drop column 1. In other words, I'm going to delete row 1 and delete, and I'm going to get 1. Altogether. And when I write A, what am I saying? I'm saying delete row 1 and column 2. Then we're going to delete and delete, and you're going to get left with 3. All together, guys. Then I'll say A 2, 1. What do I mean? Tell me what you're left with.
3.
We're left with 3. And then what are we going to be left with? All together. Then call these things here minus. These are minus of A. Now these are minus of matrix A. They are called the minors. You will see this name in your book. They are called minors. Maybe you already seen it and you were surprised. What is this? Those are minors, isn't it? Okay. Then on the other side of this line, I'm going to produce another thing. What am I going to produce? Check. I'm going to produce something I'm going to call C, R, capital letter C, R, C. R for row, C for column. And this, I'm going to give it this way. If you check this is what I got there, isn't it? Okay. And this is going to be multiplied by A, R, C. And they call this cofactor. Otherwise, what we have here, we've got the minus and the co-factors. I'm going to produce it here. So what I'm going to do, I'm going to start by producing C11, where I'm going to say minus 1 to the power 1 plus 1 multiplied by A11, and the A11 is 1. So the answer is 1. I'm going to get here minus 1 to the power 2. Then I get 1. And multiply by 1, I get 1. Then I come to C 1, 2. What's going to happen here? I'm going to have 1, 2. Then I got 3 here. And the 3 to the power minus 1 to the power 3 is a minus, isn't it? So I'm going to give a minus 1. Multiply by A12, which is a 3. There it is. Then I get minus 3. Are we together? Yeah. Then I come to C2, 1. Then like this, I'm going to have a 2, 1, which is going to give me a 3 again, giving me minus 1. It's going to multiply by C2, 1. What is it? A 3. Multiply by 3, then minus 3. Then a C2, 2. Then I come here, put 2, 2, get a 4. 4 negative signs are going to give me a positive, isn't it? Then positive 1. Multiply by a C2, 2, which is a 2. And then we get here, what? A 2. Then from these 2, from these 4, which I call cofactors, I'm going to get something called a cofactor matrix. A cofactor matrix, which is 1 minus 3 minus 3 and the 2. That's the cofactor matrix. I didn't get there by equations. I got there by what we've just learned. Are we together? Yes. Now, check this. Observe. Observe. This is not like this. This is the opposite of that, isn't it? You see that this is 2, 1. Here is 1, 2. Do you see that? Remember what I said before? I said you swap around these 2, isn't it? There is the swapping around 2. They already swapped. Without swapping them, they've already swapped. But we've got a problem with one thing here. This matrix is not a very good one. Why? Because these 3 and these 3 are equal. Then we're not going to see what we want to see. But I'm going to tell you what normally happens. What normally happens is, after this C, this cofactor matrix, we get something called C transpose. What do you mean C transpose? We mean a row becomes a column. A column becomes a row. So this row will come 1 minus 3. And this row will become a column as minus 3, 2. And this matrix is going to be called the adjoint of A. Now, being the adjoint of A, what does this get us to? Remember what was the determinant, the inverse. The inverse was 1 over the determinant multiplied by something like this. Isn't it? Yes or no? It was this. Do you remember? Or you don't remember? Oh, guys, now you're not talking to me. What are you saying? Do you remember or don't remember? Come again? The determinant was 7, isn't it? Yeah, but I'm saying it was the matrix was coming there was multiplying something like this. Do you agree? Yes. Okay, but what is this now? Is the adjoint of A. And the notation we're going to just say add J of A. And then here you're going to say here multiply by the add J of A. Now, let's conclude. Listen to me carefully. We've left the equations. We took the matrix as it is. What did you do? We calculated its minors and we ended up with its cofactors, isn't it? We transpose the cofactor matrix and then we get an adjoint. And from the adjoint, we immediately land at what? At the inverse. Out well. Let's quickly do this thing for a matrix which is different from this one, because this one is a bit cheating. Why? Because the 3 there, we don't see the difference, isn't it? So let's take a different one. This one, A equals to A, B, C, D. Let's take exactly that one. What's the determinant? Suppose it's not equal to 0. Is A, D minus B, C, isn't it? Now, let's get A, 1, 1. Is it not D? It's D. A, 1, 2. A, 1, 2? C. A, 2, 1. What is it? B. A, 2, 2. What is it? A. Guys, make sure that you see what I'm doing. Don't get surprised later on. Ne? Okay. Then these are minors, isn't it? Then we come to cofactors. Cofactors say the cofactor RC is minus 1 to the power R plus C multiplied by ARC. Let's come here. We have 1, 1. It's positive. Or we have D. Do you agree? This is C, 1, 1. This is going to be positive because this is 1 plus 1. And the A, 1, 1 is D. That's it, D, isn't it? Then we come here. C, 1, 2. We come here. This is 3. That gives us minus 1. We give a minus 1 there. We go to 1, 2. It's a C. We put that C. Then the answer is minus C. And then you come to C, 2, 1. What is this? This is a 3. And this gives a negative sign, which is that we go to A, 2, 1 is B. We multiply there, we get minus B. And then we get to C, 2, 2. These are capital letters, remember? Okay, C, 2, 2. Then we get here a 4. That gives us a 1. Multiplied by A, 2, 2 is an A. Then this gives us A. Now, just say this is a row for the cofactor matrix. This is a row for the cofactor matrix. Therefore, cofactor matrix is D minus C minus B and A. And you can see this is not what we had in the inverse. Yes or no? So what do we do now? We go to transpose. This is adjoint. We make this row a column. It becomes D minus C. We make this row a column. It becomes minus B A. What is that? That is the adjoint of A, not of C. This is a cofactor matrix. This is a transpose of cofactor matrix, and that is the adjoint of A. And then what's the inverse? The inverse, we said, is going to be A 1 over AD minus BC multiplied by D minus B minus C A. That's the thing. If you check, this is what we got here. Do you see that? But there we got it by using systems of equation. Now we've just got it by using cofactors and minors. And then let's just stop there just for a second. Just for a second. Let's look at this. Just look at this. Look at this. We've got C. We've got your C here being what? being D minus C, and what? Minus B and A. And what is your A? Your A is A, B, C, D. Check what I'm doing. Just don't write anything. Just look at what I'm doing. I'm coming here to A11, to 11, and coming here to A11, to 11. I say AD. I'm coming here, and coming here and say AD. Then I'm coming here, and I'm coming there. I say minus BC. What is that? Determinant. I just moved along this and along that. Check. This is one situation. What I was doing there, I was moving along a row. Then I come here. I'm moving along a column. And I move here along a column. That's situation number 2. What do? I say AD minus BC. That's along a column. I come here, here, move along a row. I come here, I move along a row. That's situation number 3. And then what do? I say minus BC plus AD, which is exactly the same thing as AD minus BC. That's another way of calculating a determinant. That's called calculating determinant using cofactors and minus. Right. Guys, at that point, go and practice determining inverses of 2 by 2, calculating determinants, and even try this method. Otherwise, at that point, notice one thing now. We are ready to calculate determinant of a 3 by 3. We are ready to determine an inverse of a 3 by 3. At that point, thank you for listening. The presentation ends there. We meet in the second presentation. We're going to deal with what we've just mentioned. My name is Charles Wasfan Msipa.